Today I'm going to show how to foam cut an airfoil, and this is going to be a tapered airfoil, and we're refining this process a little bit. So first thing I did was I designed the airfoil using SketchUp, Google SketchUp, and then printed out these templates of the airfoils on a laser printer at a 1-to-1 scale so that it's an accurate size representation. And then you can see I added some extensions onto the airfoil shape to just allow me a starting ramp and an ending ramp for my hot wire foam cutter to help get the ends aligned when cutting starts. So I do a rough cut around this template, and then I'm going to spray tack it to a piece of thin aluminum sheeting that's just like an HVAC part that's available at the hardware store. It's very thin, very flexible, lightweight aluminum, and very easy to cut with a shear, which is the primary requirement for this. There, so I've got my templates glued on the aluminum foil. This is a brief explanation of my hot wire foam cutter. So this little modified outlet here, besides being not properly electrically enclosed, is kind of the heart of the hot wire cutter besides the wire itself. So what I've done is I've got a power cord right here, and I've wired it to an outlet. Now what's intended is that the hot side of the power flows into the receptacle, and then you can plug in loads to get the amount of current that you need to heat up the wire for the cutting speed that you're looking for. So in my case here, I've got one of these goes to a 500 watt halogen lamp. And then in the background, kind of there, you can see there's another lamp, and I've actually got a 300 watt incandescent bulb on there. So I'm putting about 800 watts through here, so somewhere around 7 amps. Now, so the hot goes out through the loads and then comes back to the neutral. And this is where the neutral wire, comes back and goes out to this blue wire here, and continues running in series. So all the current from my lamp loads wires in series back out to a wire, got an alligator clipped. The current flows through the wire and then back and connects back to the neutral and then flows back. Now it's important to note that this is being used on a ground fault interrupt receptacle. So what that means is that if you would somehow come into contact with this circuit and some of the current would flow through you to ground or through another object to ground, it would trip the circuit. This is not fail-safe by any means. You still can be harmed. So you know this is a 120 volt setup. Most hot wire cutters are done with low voltage DC. Then you need a power supply and a high current transformer and so forth. So this is definitely poor man's, but if you don't know what you're doing around electricity, I would not recommend this. So anyway, and this is my cutter, so I'll show it to you in action. So I will plug it in. As soon as I plug it in, the wire starts getting hot. There was some residual foam on there, and you should see that begin to melt away in a moment. I don't know if you can see it smoking there. Okay. And then this is just my hand shaping tool. So I'm just trying to cut some excess to get my blank down to the rough shape that I want. So I'm just gonna kind of guide this manually. You can see how it melts right through when it was preheated there. So I just kind of guide this through. And notice I'm holding on, I've got fiberglass insulated standoffs, and I'm just going to guide this through the foam. I ultimately want to get down to that line there, but so it'll take several passes through here. I'll pause the recording until I get done with this. So I've just finished making that hand cut with my hand tool, so you can see there's the cut edge. I went along there and then came back against the straight edge. And now I'm going to go up to this line, so I'm going to put a stop up against that line and then cut again. What I'm set up for here is just doing a cutoff, a very straight cutoff of the block of foam to get it to the right size for the profile cut for the airfoil. So I've just got the foam clamped down to my work surface and overhanging the edge of the work surface. And then what I've got here, this aluminum framework, if you can ignore the background, this aluminum framework is just that, and it's spring-loaded so that it keeps tension on the wire. So here's the spring, there's the beginning of the wire. Wire goes around a pulley, around another pulley, and here it goes around a cable tie, which acts as an insulator, electrical insulator. Then it picks up with another wire, and this is where I attach my first lead. So that's where the heat's going to begin. Then it stretches all the way down to the other end. There's the other wire, so that's where the heat's going to end. That's actually the hot wire, which is receiving current from my electrical load. And then it just goes to another insulator there. It's a fiberglass rod that's attached to the other side of the bracket. So let's do a straight cut, and this is just going to be a gravity feed. So the weight of the framework is going to cause it to feed. So I'll plug it in, and it's going to drop off when it gets down to the end. So I activate my load, and there it goes. And normally, if I wasn't holding the camera, I would shut that off just a little bit earlier and avoid that drop, but you get the idea. Now that the tack adhesive is dry, we're going to trim the aluminum around the outline. So one of the things that I've noticed helps the process is if you pre-trim to kind of get close. That way when you're making your final cut, the piece that's coming off is thin and can curl out of the way and not interfere with you curving the shear. Also, when you're cutting, the side that will be wire cut, you know, the outside, the front and the back and the bottom are not that important. But when you're cutting this edge that the hot wire is going to drag across, it's important to never cut all the way to the tip of the shear, because that'll leave a bump or a little notch. And also try to, when you open up and re-grip to make your next cut, try to kind of wedge it in there good to your last cut. Otherwise, again, you'll get a little burr. So I'm just going to follow right along this line, and you can see how that edge is curling up the piece, the scrap piece. I'll just continue cutting this. Just a note, if you're going to use a metal guide as a hot wire template, use very thin metal. Otherwise, if you're going to use heavier metal, like a sheet of aluminum or something like that, that's thermally conductive, it's important that you don't mount the template directly onto the edge of the foam. What will happen is, as the wire moves along the template, the cold template will draw the heat out of the wire, causing it to cool down. And then, because it's cold, it won't cut the foam that's directly adjacent, and the wire will stop moving. When the wire stops moving, the rest of the wire is still hot, and it kind of burns a cavity. And so what you'll see are all these ridges in your surface when you are done cutting. Instead of a nice smooth surface, you'll see ridges where the hot wire advanced and then stopped and advanced and stopped and advanced. One of the things I've learned through trial and error in doing this. Now that the template is cut, I just want to rub my finger along the edge where the hot wire is going to trace and feel for any irregularities or any burrs. And if I feel anything, I'll just take a fine grade sandpaper and kind of just smooth out those rough edges so that my wire will follow along very evenly and not get snagged as it gets pulled across this surface. Okay, here's where we're getting set up for actually doing the wire foam cutting. So I've got my work surface here. I've got my blank of foam. Now this is Foamular 250, Owens Corning Foamular 250, which means it has a 25 psi compression strength. The 150 would work just fine as well. It's 2 inches thick, so I've got plenty of excess thickness. I'm going to cut my part right out of the middle of it. So it's a tapered airfoil, so I've got a wider on that end, narrower on this end, and I've got these lead weights sitting on here just to keep it pressed against my work surface, which is straight because of the reinforcing straight edge on the bottom of it. Just blocks to hold it down. What I'm going to do is use the tacky adhesive to attach the airfoil template, which is a thin piece of aluminum, to the end. And I'm going to have a little bit sticking out on the template past the edge so I can rest my wire on to get it started. And I'll take the other end. This is the tip end of the airfoil, and attach it like so with sticky adhesive. And once that adhesive is dried, we are going to be ready to cut. All right, here's one of the secrets to hot wire foam cutting, is that if your object or the profile that you're cutting is not the same width on each end, so in my case I've got a tapered airfoil. This is the tip of the airfoil, and it is half the size of this part of the airfoil. So what that means is that if I want to get the correct shape, my wire has to move twice as far. You can see the wire back here where the red alligator clip is. It's going to have to move twice as far as the wire on the other end. So the way you control that is, okay, this is my tensioning, my pulling string, which is hooked around my wire, and then it goes over a pulley and to a drawbar or a weight bar. Okay, so this weight bar, the distances are critical. Okay, so there's a pivot point back here, right here, and then there's the first draw point where this will pull the narrow edge, and then farther down. So the distance from the far pivot point, or the far draw point, to the pivot point right there is twice the distance as from this draw point to the pivot point. And that's because my airfoil is twice as wide on that end as it is on this end. So you need to keep the ratio of this weight bar, draw points equal to the ratio of the width of your part. And you'll see that in action once we get cutting. By the way, I have the ultimate in economy in making this hot wire foam cutter. So instead of using the nichrome wires that are more expensive, that are designed, that have a little higher resistivity, there are some advantages to those. But I just use in 20 thousandths thick music wire that I got online. We're getting set up. I'm almost ready to put the heat on and start cutting. Still waiting for the templates to, the adhesive to dry, attaching those. But what I've also done is I've attached a weight in the middle of my tensioning bar, my pulling bar, to draw the wire across the part. Just take some guessing, trial and error to see how much weight you need versus how much heat you're putting into the wire. Okay, ready to start hot wire cutting finally. Notice that I've got the leads attached and I've got slack in those leads, so when the wire starts moving, The lead can easily follow along and not get snagged. In this case, I'm using the metal frame, and I've also got a ground wire attached to the frame, so that if something should go awry and the frame would get energized, my ground fault interrupter would trip it out. Same thing on this end, the lead is set up with slack in it. The wire is pre-positioned on my template right at the edge. Now you notice there's a leading straight piece before I get to the airfoil. That's half the distance on this end as it is on this end because of the way my drawbar is set up to draw this end 2 times faster than the other end. Okay, we'll get set up here. When the lights come on, that means the heat is on and we are starting to hot wire cut. Now I'm just getting ready. I might have to help it a little bit, lift up when we get to the beginning of the airfoil. There we go. It's cutting nicely now. Moving right along. Perfect. It's not getting snagged. Make sure it keeps moving, doesn't get snagged on anything. Moving along. Okay, I'm almost at the end of the airfoil here. I've got a little farther to go there, so it wasn't quite perfect, but that's why I start on that end. Okay, I think I'm done. Okay, that was not perfect because I need to pull a little bit more on this end, so I need to change my ratios on my drawbar. Okay, so let's see how we did. You can see from this end it looks pretty good. It nicely followed the airfoil. Looks very smooth with very few ridges. But I will notice as we get down here, you can slightly see some ridges right there and right there, which indicates that probably snagged a little bit. There might be a little rough spot on the template. Matter of fact, I know there's a rough spot right there. Anyway, but there's maybe a little bit also on the leading edge here. The profile isn't exactly perfect. It's a little hard getting it to come up over this hump here, synchronized on both ends. Ideally, it would be best if you had 2 heads and 4 hands, but anyway, look at the nice smooth surface, very uniform, and you kind of brush it off and it gets those little fuzzies off of it, and you've got a really nice smooth surface. Okay, now I'm set up to cut the other half of the airfoil, the underside or top side, whichever you want to look at it. So I have flipped my template around. And so now the tacky adhesive is sticking out here. So what I decided to do was drill some holes in the template and just use sheetrock screws to attach them to the foam. So they're not going into my part, they're going into the blank part of the foam. And I did that on both ends. Matter of fact, going forward, that seems like a better way of than dealing with adhesive anyway. So, okay, I think I'm ready to go. Again, this is going to be very tricky because as we saw last time, the 2 sides didn't draw at exactly a 2-to-1 ratio. And I've got a couple of potential snag points here. So I'm going to have to monitor this very closely. And I may have to interrupt the cut. There's a spot on this one that's got a little snag, and I'm going to need to help it over it. There, it's past it. Okay, good. Now this time I put a little counterweight on the back side of the drawbar. You see there's a wire or a string suspending it just to help hold it up so it can move around freely. I put a little counterweight on the back side so there wasn't so much pressure pushing down. That'll help it glide across the template a little easier and hopefully not get snagged. Now this side's moving pretty fast, so I'm going to stop it. And that's not the greatest thing to do, but I can definitely see that this side is almost ready to go to the leading edge. I'm going to need to correct that and get this side to draw faster somehow. I'm going to pause.